Okay, so that was very short introduction to QML. A couple of examples just to show you what it is, what QML applications are. And we'll get, in the demonstrations, we'll get into details a little bit more. So let's go forward to the next section, which is outstanding user interfaces. And at this point, I'd like to point out that there will be a number of workshops tomorrow on day 2 of this conference. Cute Quick Components for Designers, which covers Symbian components, UI guidelines, things like that. And if you are mainly interested in developing Symbian applications, targeting Symbian platform, then that's probably quite an interesting workshop. Then there's another one, Qt Components Deep Dive, which goes a little bit deeper into the technical details of Qt Components. Also tomorrow, something you might be interested in. And also there will be deep dive into MeeGo and Nokia N9, which covers more MeeGo-specific things. And I hear that there will also be talk about components and other UI guidelines, things like that. In general, on this section, we will be covering Qt components. We will be covering UI design approaches. And for both of these, we are targeting mostly Symbian platform. I think we will be able to talk a little bit about what differences there will be between Symbian and MeeGo, but we won't go very deeply into that area. Also, this section is something that I'm basically going to cover relatively quickly, partly because I'm a developer. I'm not a designer. And my eye for design is, well, not very good. I'm not able to design nice-looking UIs that really catch the eye of the users. That's something that designer does. And these tools enable you to work closely with the designer. And that's the beauty of the situation. In an area where both you and designer can easily understand what's going on and what the limitations, what the advantages of the technology that we are using are. Okay, so let's go to first some topics about guidelines and what you need to take into account when you are designing application. First of all, let's divide applications into 2 categories, productivity and immersion. Productivity applications would be something like, well, let's take as an example the application that's provided for this conference. There's this application developed by Futurize that brings you the schedule of Qt DevDays. And to me, that would seem like a productivity app. It's something that you want to make sure that it's simple to use, easy to use. And when the user comes to the application, he might not be interested in seeing some amazing transitions, amazing UI implementations. He wants some specific task done, and he wants it done quickly. So that kind of application should be designed so that the user is in charge. So keep them simple, keep them efficient, and we'll show a couple of ways how to design this kind of user interfaces. Then there's another one. There's immersion, which is usually something like, games maybe some demonstrations, things like that. Applications that you want to be able to catch the eye of your user, to be able to capture the user and entertain. For these, it's probably best to use full views to make sure that that application is in focus. So there's a couple of different navigational structures. We have tab bar navigation, and we have drill down navigation. Tab bar is basically for UIs that you want to switch. I mean, you have parallel UIs, parallel things like different categories of settings, for example, or different views into contacts list on your device, something like that. And drill down is for information that's more tree-like structured. So let's say that you want to implement an application that shows you weather in some specific location. Your application might have first a list of countries, then a list of regions. So when you select a country, it selects that country and goes to another view that goes into more specific details. And then from that area you select a city, for example, and yet again you go into more specific details. So we could consider that a drill down UI. And you can of course combine these as a third form, implementing tab bar and drill down as tab bar and back navigation, as one level of the drill down UI approach. So let's talk a little bit about tabs. As I mentioned before, tabs enable you to show different parallel content easily. There are some guidelines for how to design these, where to place your tab bar, what kind of things to put in your tab bar. And the fact is that quite often these guidelines are platform specific. So what does that mean? For example, in this we are basically targeting Symbian, and we have this advice here to not put a back button in your tab bar.
Sorry, which is the tab bar here?
In these examples. The question was, what is the tab bar in these examples? In this case, this part, and this part are the tab bar. And one guideline is that you should never put your back button in the tab bar. Then again, you have the drill down plus tab bar navigation, the tab bar plus back, and that's basically against this guide. But as mentioned before, guidelines are something that are platform specific. So you need to go and read your platform guideline, get intimate with it, and understand it. And then you'll know how to implement your application so that it provides the user experience that's expected from applications on that platform. And then you also know what rules you can break. But, as mentioned before, the guidelines are on the interweb. They are available. Just read them. We have one more example. This is a drill down application, drill down style application example. I don't know if you can see it clearly enough. But in this example, what we have is that we have a number of albums, and we can select different views, basically to our music library. We can browse by artists, albums, songs, playlists, etc. So when we select one of these, we go into another view to more details. In this case, the detail is that the information is organized by certain criteria, in this case, by artists. And there we can see this information about the artist, list of artists available in this music library. So let's select one here, and we get to see all the records from that artist. And then we can go and select one to come into a view. Let's go to Qt components. So what we have discussed previously is basically a setup to why we want components and why we want to use them the way that we do. First of all, Qt components is a component library that provides you with a number of components that you can use to design your user interface, so that you don't have to implement every element by yourself. It's designed to speed up the development and provide some nice and really functional components. There is one thing though. The components are at the moment available for a couple of platforms, for Symbian and for MeeGo. And they don't act completely in the same way. And that shouldn't actually be surprising because they are different platforms. And for different platforms, you have different guidelines. And this means that when you implement your Qt quick user interface, it's probably the best idea to make it so that you implement a separate UI for each platform that you want to target. And Qt Quick makes this really easy because it's so easy to write new UIs. Let's cover a couple of basic elements, and these are also something that we'll be using in the demo section, the fourth section of today. So first, we want to be able to use these components. We need to take them into use. We need to import the module that provides the components. In this case, we are using Symbian, so we import Nokia Symbian 1.1. And this gives us Qt Quick components for Symbian. There's a number of elements, like, for example, window, status bar, toolbar. Now, we don't go into details of all the components that are provided because you can quite easily go and read about them yourselves, and we don't have much time. But we'll cover these in a high level. So window is something that's designed to be a root component for Symbian UIs. It provides you with a window abstraction. It can contain things like status bar, toolbar, things like that. For MeeGo, things are a little bit different. In MeeGo, you usually use something called page stack window as your main root component. And the funny thing is that page stack window is also available on Symbian, but they might act a little bit differently. So that's something to take into account. there are a number of similarly, well, basically most of the components are named similarly between Symbian and Mego, but there are differences in how they behave. And once again, they are different platforms, so you need to take that into account. Okay. When we define our window, we can use things like page stacks to implement a mechanism for showing different pages. So we divide our application to separate views, known as pages. And the page stack is the element that manages those pages. And from here, we can see that it basically enables us to implement the drill down UI.
Just as we've seen in the,
Can we have the microphone, please?
just as we have seen in the example, a few. Just as we've seen in the example a few slides back.
Yes.
Just the same.
I'm sorry, is that a question or
No,
are you making comments? Okay, yeah. Okay, and these page stacks are something that can be managed dynamically. We can add and remove pages during the execution of the application. Like here. So in this example, what we do is that we react to, we implement a function to load a file. And in that function, we create a Qt component from a file, we instantiate it, and we put it into a page stack. And that pushes a new page into our page stack, bringing it into view. And we can easily execute that function by reacting to mouse area. So we have a dynamic UI that loads new pages when the user clicks on the mouse area. Okay, so we are able to use different elements. There's a bit of a problem with my slides. I seem to be missing something from here. Okay, well, we'll just go forward to styling. So basically, when you are building your application, targeting Symbian UI, for example, you want to use the styling provided by your environment. And styling is something that the user has properly set up to their preferences by changing settings, changing sets of icons, things like that. And you can access the current style of the environment by using number of properties provided by this platform style. Basically, for images, there's theme URL scheme that you can use, or image scheme and theme path that gives you access to themed versions of certain UI elements. So instead of implementing your own UI elements for these symbols that are available, you should use the themed elements from your platform. And same goes for a number of common buttons. You don't have to do those yourselves. You can just use the platform-provided styled versions. Then one more nice component that's available in Qt Components, ScrollDecorator. It's something that enables you to add scroll bars quite easily on your Flickable content. For example, list view is something that inherits from Flickable. Flickable itself being an element that you can easily flick in different directions, like how usual UIs are implemented in mobile phones these days. ScrollDecorator is something that you can use to add simple representation of the position where you are scrolling indicators into that view. Then we'll cover a number of different elements, different components provided by Qt Components. First, there are some basic text input elements. So you can see that we have text field, text area, the usual stuff. And then there's a placeholder text, something that you can show as a hint for the user, what you expect to be typed into that field. It's something that's quite important when you are dealing with a mobile UI that's probably a little bit cramped. You don't have lots of space, so you need to take advantage of all the space that you have. And this way, you usually can get rid of a label or two. Okay, then we have a collection of buttons, different buttons, the usual button, tool button, things like that. We have menus. Once again, something that we can easily define from our QML UI. Like this. The declarative model makes it really easy to implement these kind of structured elements, like menus, for example. You don't have to worry about populating your menu with different items, creating the menu, creating the items, adding them to menu, adding the menu to window, things like that. You just describe what you want, and QML takes care of it. Okay, we have other elements like dialog boxes. And that's a little bit more code, but still quite simple. But we don't go into details in this case. Then we have the tabs that we mentioned already. Basically what we have is tab bar that contains tab buttons in a tab group. Or tab buttons and controls a tab group that contains a number of pages. And in this case, when we have the first button selected, we get the first page. If you select another button, then you get a new page. And a bit of code. This is once again something that we are not very really interested in this code at the moment. We have examples and demonstrations for that. So let's go forward to animations. we just covered Qt components, and this is not part of components. Animations is integral part of Qt itself. You probably know animations from Qt, and in Qt you used animations for animating changes in properties. And that's the same with QML. When we speak about animations, we don't speak about cartoon characters that are running on the screen or things like that. We are talking about animating UIs, animating transitions in UIs. For example, if we have a view like this, and we have nice smiley face image in there, and we want to move the image from the top of the view to the bottom of the view, and we want to animate that transition. We can use animation for doing that. How do we do that? What we can do is that we'll define our view. The rectangle is our root element in this case. We define image, which is this image, and then we define an animation. In this case, sequential animation on Y. So we essentially what we do is that we tell the image that we want to add an animation that targets this image, and more specifically, the property Y on this image. So the animation is sequential animation. Inside sequential animation, we can add a number of other animations. In this case, number animation, pause animation, and number animation. So the first animation, it targets the image. It moves Y property from whatever it is to 300 minus image height during 2000 milliseconds. And it defines something known as easing. Easing is the way that you want the animation to be executed. Usually, your animation runs linearly, which means that it runs from, for example, from 0 to 100, incrementing in equal steps. But if you define easing, you're able to modify how the animation runs, how the value is, for example, incremented. In this case, we want something called easing.outbounds. The outbounds behaves so that when the image, or the target in this case, reaches the end of the defined target, or target value, it bounces nicely. It goes like bong, 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 like that. And this is what it does. Then we have pause animation, which pauses this sequential animation for 1000 milliseconds, meaning that when the image goes down, it stays there for 1 second. And then we have yet another animation, number animation, again, that basically reverses what the other one did, but using different kind of easing. And the sequential animation makes sure that these animations run one after another. So that enables us to animate our UIs, to animate transitions in nice ways. Let's go into a bit more details. So we have a number of different animations, as we saw previously. We saw sequential animation, we saw number animation, and we saw pause animation, right? Well, they all inherit from elements known as animation. And sequential, parallel, property animation. Sequential we saw already. So that's for animating, combining different animations to run one after another. Parallel is something that you can use for combining different animations so that they run at the same time in parallel. And property animation is something that animates properties, modifies the values of properties. Once again, specialized into 3 different sets: color animation, number animation, and rotation animation. Number animation is the one that we saw already. The others are more specific cases for different kinds of values, like colors, rotations, things like that. For rotation, you can specify the direction to which you want to rotate. Number is just numbers in general. Okay, so we have different kinds of animations. We have, we can use these differently. We can use animations as property value sources. Basically something that we saw already. Animation on Y. Then we have behavioral animations, which are animations that react to changes. So instead of driving all the time, they react to change in a property. For example, if you change the X position of an item, you could put in place a behavior that animates that change. We'll see an interesting case of using this a bit later. But other things that we have, we can use animations as targets for signal handlers. Basically, using the signal handler to tell the animation to run. Then we have standalone animation, meaning that we can define an animation and keep it separate from other elements and just tell it to run. We can change the target, do many things. And then finally we have transition animations, which basically means that we can use animations in transitions of QML state machines. So now we go to some details of these specific types of animations, but I think we'll just go through this in a high-level overview, not go into the specific details. This is just to give you an idea of what capabilities this mechanism has. Okay, so first, as we described, we have animation as a property value source. So this is something that we saw already. Property animation on X. We define the animation, and the animation drives that property. It starts changing the value of the property. Then we have behavioral animation here. In that case, we define the behavior on X and Y. You can see that there are no to and from properties set. Just duration, just how long we want this animation to run. What this means is that as we change the value of the X and Y properties, the QML animation takes care of, makes sure that when the value changes, let's say from 0 to 100, you just assign new value, but the animation makes it animate. It animates all the steps in between those values. So you just set it to, let's say, 100, and the animation drives it from 0 to 100, giving it a number of different values in between, and making your UI, if you so choose, to feel more smooth. Really simple mechanism for implementing nice transitions in your UI. Okay, then we have animations within a single handler. Just an animation, very similar to what we have seen before. This time we are specifying the target of this animation. Because our parent is the mouse area, we don't want to target that. We want to target something else, the rectangle. Then we specify which properties we want to change. Previously, we knew what these properties were because our animation was basically bound to those properties already. But now we have more individual animation. And we need to tell it the target, properties, and then we specify how we want to animate the target and how long we want the animation to run. Okay, a bit more general, standalone animation here, a property animation in this case. And now we give the animation an ID. So we are just adding more fields to same elements. Everything else is something we have seen already. And yet again, we give the animation an ID. We are referring to it by that ID and modifying its properties. We can change the to value and we can make it run. We have a couple of different ways. We can use the running property and modify it directly, or we can just use a function to do that. Easing curves is something that we already saw. So we use those to modify how we want our animation to run. There is an example available about this in Qt examples. It should be provided with the SDK. I'm not sure if it's still the case. In those examples, what you will find is an application that shows you different easings, enables you to run a simple animation using different easings. And that really illustrates what the easings mean, how to use them. So go there, play around with the SDK examples, and you'll find it. This is a bit fast-paced, but we'll go to another area right now, which is QML model view. So in this case, let's say that we want to show the user a list of information. In Qt, what we had is we had models, we had views, the whole model view framework of Qt, but it's a little bit difficult to use. But in Qt side, using those models is really easy and straightforward. And also we can define models easily. However, the models like this one, for example, this is a list model that consists of list elements. It's good enough for simple cases, but for anything more complicated, anything that approaches an actual application, we'd want to use an actual model, something that we can control, where we can easily add more stuff, and that's probably something that we want to implement on the C++ side. And it just so happens that QML is compatible with QAbstract model from Qt. So in the next section, when we learn how to communicate between Qt, the C++ code, and QML, the JavaScript code, we will see how we would be able to bring a QAbstract model based model from Qt side to QML and implement a view for that model in QML. But this is a simple example. This is what we have: a set of list elements with title and picture for each one of these. This is what we want to see. And this is simplified version of how we make it happen. So this is our model. This is the final view. And these are our delegates. Or this defines the delegate that we are using for rendering each of these items of our model. So let's see some examples of using the actual view. We have myModel.qml, which is our model, just the model that we saw previously in a separate file. We have modelView.qml, which implements a list view for displaying data. And then we have this delegate that we saw before that implements how the item, any item in the data, should be made visual. And this is what we want in this case. We want a list of person details, name and phone number. So let's create our model. This is the model.qml. We have number of list elements in here for Bill Smith, John Brown, and Sam Wise. As you see, the list element is very similar to what we saw in the previous example, but the properties have changed. This is something that we are using in the models. The list element will accept any property. And then that property, or those properties, will be made available to the delegate. So they are able to communicate, able to provide this data to the actual delegate that takes care of showing it. And finally, we want to wait for the animation. Okay. We want to implement the whole view. So we create a rectangle first, which is the background in this case. Then we have the delegates that we discussed earlier. And we have a highlight item for highlighting the current item that we have selected. And finally, we have the list view itself, which brings all these other things together and makes it happen. So we'll make it fill the parent, the whole view. Then we'll specify which model we want to use. Well, we defined myModel in a separate file, so we can just use it as a component and instantiate it here. Then we can use a delegate. Nice. We have specified it as a component here. And then we can use the highlight defined here. And that's all we need to implement a simple list view. By implementing more complicated delegates, we can make it visually more impressive. And the same goes for highlight as well. Some things that you should remember is that when you implement your delegates, the delegate is something that's instantiated for each item on the list. This also means that the delegate can change its visual appearance according to what it's showing. So it can detect if the name of the person is, let's say, Bill Smith, and use different fonts, different size, something like that. And that's something that's important to realize with when you are playing with these list views. one hint is that usually, or quite often, delegate is something relatively simple that can be defined as an inline element, especially if it's something that you don't want to share with other lists. So that was list view, this one, but we have also other views. Grid view enables us to display grid of items in a way similar to what we already saw with grid positioner. This is for lists or models. And then we have a third one, path view, which is a nice example of more high level, more impressive view for a model. In this case, you can define a path and make your items move along that path. When you add some touch-based interaction, it's easy to implement something like, let's say, the usual cover browser example, where you have a number of record covers that you want to browse through, and you can easily just flick and they go along some path, and then you stop and select one of the records. Okay, so we come to the flickable elements. This is actually something that we have seen before already. The flickable element is something that you can use for adding flick interaction to your UI. It's something that's obviously important for mobile touch-based devices, because these days usually the interaction model that we are using is something that's based on panning and flicking and pinching, things like that. So Flickable enables us to implement the flick element interaction. A number of elements are already flickable, but you can use the basic flickable element to make your own elements flickable, just by adding flickable elements around your own elements. Like this. If you want to make this image flickable, we'll just add a flickable element around it and define content width, content height, and they are probably something that are different from the flickable element's own size, so that the content can be flicked in various directions. So that's how it works. Lists, for example, are already flickable because they inherit from that element. Okay, so that was the second track. We were able to catch the schedule a little bit. Do you have any questions? Go ahead. Can we have the microphone, please?
Could you comment on inheriting?
Sorry?
On inheriting, you say it's inheriting properties or whatever.
Yes. Basically, what inheriting means that, let's say we have item element, which is the base element in QML. Item is the base visual element. And then we have different other elements like rectangle, image, others. And they inherit from item, which means that they share all the item's properties. So you don't have to define those properties when you are implementing your own components, for example. Does that answer your question?
Is it like in C++ you say public?
Yes. Yes.
I didn't see something like that in your source code. I didn't see mentioning the parent classes or whatever in the source code.
Yeah, we haven't actually inherited our own components in these examples. What we have been doing is that we have been using pre-existing elements. And if we designed custom components, well, in a way we did already with models. If we decided to do that, then we could easily take, let's say, a rectangle or an image as a starting point, and it would implicitly mean that we are inheriting its properties because we are building our own component based on that. But more interesting way is, of course, that we can go to the C++ side, which is something we'll be covering in the next section. And we can really access the classes that are used for building this whole mechanism. And we can implement our own custom components on that side. And we can then introduce them to the QML context. So that way we can implement our own class hierarchy in C++. But in QML, what we do is that we define custom components and take something as a starting point. Any other questions?
There is mentioned on the slides the examples will be available, or the location would be made available during the session.
Yes.
And I looked on the stick, there is nothing on it. Where are they?
The examples are not on the USB stick. That's why we make them available during this training. Basically, what this means is that I will show you the URL of the repository that will contain the example.
Can you?
Actually, I can do it, let's say, after the break.
Okay.
I'll just need to log in there and make it public, and then you'll be able to find it. It's on developer Nokia.com, so it's easily reachable, and will be, of course, available after this training as well.
Okay.
And the application that we have in there is relatively simple, and we will be covering at least parts of it during the last section. Any other questions? If not, let's go to the break.